There are many methods for finding a feasible solution to a transportation problem. Among them, this video will introduce the northwest corner method, minimum method, and the Vogel approximation method. Here we have a table for the transportation, and we're going to assume that these numbers are cost. So you want to minimize the cost when transporting items from the plant 1 through 3 to the warehouses 1 through 4. Now, the northwest corner method is probably the most inefficient way to get a feasible solution. It rarely gives you the optimal solution, and the basic idea is to just find the top left corner. Northwest means top left corner, and just fill in the maximum number you can put there. So here, plant 1 has 300 available, but warehouse 1 has 150 as the capacity, so the maximum you can put here is 150. Now, because you've used 150, 300 minus 150 is 150. That's left from plant 1. And because you've filled all the capacity, 150 minus 150 will be 0. And when you have 0, that means you can't deliver any more to this warehouse, so you have to put 0 here and 0 there. And what happens is anytime you put a maximum number on the top left corner, you either delete the row or the column including that one, sometimes both, and that leads to a smaller rectangle, but you always get a rectangle. So always this top left corner is well defined, okay? So now let's see, this is the rectangle we are left with after deleting this column. You fill this with 150 because that's the available and that's the maximum this warehouse 2 can hold. So we put 150, and because now 0 capacity is remaining, and this plant 1 sent everything, so it's 0. So that means 0, 0, 0, 0, and you end up with this square. Again, 350 to 350, that's convenient. So 350, so you have 0, 0, 0 is remaining, 0 is remaining, and then 200 goes into 200, so 0 remaining, 0 remaining, and that's it. That's the northwest corner method. Then the minimum method, by the way, sometimes the table values here, they mean profit, and they want to maximize some quantity. In that case, you look for the maximum values rather than minimum value. But here we're doing the cost, so we're doing the minimum. Okay, so we look at the entire table and look at the minimum value, which is 1, and we want to make the most use of this. And that means since 200 is available and 150 is the capacity, you can at most put 150 here. 50 is still left in plant 3, and you met all the quota for warehouse 2, so the other ones are filled with 0. Now once you have that, then look at the remaining cells, and among the remaining cells, find the minimum value. I see it here, 2, right? Since 300 is available, but 150 is the capacity, we can only send in 150. 300 minus 150 is 150. And we put 150. And then 150 minus 150 is 0. And because you have 0, these will now be 0. All right, and then among these, 3 is the minimum. It can accept 350, but only 150 is left to go from plant 1, so you can only put 150 here. 0 is left. 350 minus 150 is 200. And then because you have 0, this should be filled in with 0. And you have this. Among here, 4 is the minimum, so you can put the maximum here, but 50 is the only remaining amount, so you have to put 50 here. Now that's 0. Whenever you have 0, you should put 0 here, and then 200 minus 150 will 200 minus 50 will be 150. Okay, and then now you just have these two, and 350 is what's left, so you put 150. 350 minus 150 would be 200. you put 150 here. 150 minus 150 is 0, so everything's filled in. And then 200, and 200 minus 200 is 0, so that's the solution given. It's a feasible solution given by the minimum method. Now, this is a case where you have exact same amount of supply and demand. There are some other examples where you may have more supply. In that case, nothing changes. It's still the same method. But if you have more demand, then you may have to add an extra row that has the dummy variables. Okay. All right. So now let me introduce the Vogel approximation method, which is the most complicated one, but at the same time, it is the most optimal one. It often actually gives you the optimal solution. Of course, to get the real optimal solution, you have to do something called the Modi method from these feasible solutions, but often the Vogel approximation method does give you the optimal solution. All right, so let's think about what this is. So Vogel approximation method uses the idea of penalty. Okay, the reason I have these extra columns and rows is so that we can put the penalty here. So these are penalty. And the concept of penalty is this. The best number on this row is 2 because it's the smallest, right? But what's the next best one? It's 3. So it's about, if you choose this number, then you fill in with the maximum possible, then you might not get to use the next best number, right? And that's like the penalty that you have to think about. So it's a little bit more elaborate kind of method because it uses the penalty to find the best value. And what you want to do is you want to find the one, you want to fill in the one with the maximum penalty so that you get you don't get penalized that much. Okay, so let's see. The best value here is 2. The next best value is 3. 3 minus 2 is 1, so the penalty is 1. Here the best value is 2. The next best value is 4. 4 minus 2 is 2. And you never put negative numbers for penalty. You just take the difference. You put the positive number. Here the best number is 1. The next best number is 4. So 4 minus 1 is 3. You put 3 here. Best number is 5, and then 6. 6 minus 5 is 1. 4 minus 3 is 1. 2 minus 1 is 1. And 4 minus 2 is 2. Okay. So among here, you look at the penalty, and I see that this is the maximum penalty, right? So use that. That means you want to use this row, and using this row means you want to make use of the best value in this row, which is this one. Okay, so that somehow coincides with the minimum method's choice, but here we have like a better hunch that this should be the best choice. Okay, all right, so we put 150, that's the maximum you can put here. 150 minus 150 is 0, and then 200 minus 150 is 50, and then because it's 0, now this is filled in with 0. And then you repeat this process. You do another penalty. Okay, so here it's still 3 and 2 are the best numbers, so it's the penalty is 1. The best number is now 4. The next one is 7, so it's 3. The best number is 4, and this is 5, so it's 1. And then here, actually, because this column only changed, these numbers really didn't change. So in this case, the penalties just come down with it without any change. So that saves you some time. All right. So here I see that 3 is now the maximum penalty. So we go to the next, the best value here, and use up the most you can use up here. So 150 is the capacity, so you put 150 here. 350 minus 150 is 200. And 150 minus 150 is 0. And because you have 0, this is put as 0. And again, because these columns are filled in and these are untouched, these still become 1 and 1. But for these, I still have to I now have to calculate the new penalty. All right, 3 and 5, that's just 2. 7 and 11, that's 4. 6 and 4, that's 2. Okay, so it means that 4, since that's the maximum penalty, you have to fill in this one. Okay, so put 200 here because that's the maximum you can give to warehouse 3. 350 minus 200 would be 150. And 200 minus 200 would be 0. So that means this is 0. Okay? And because now this row is filled in, and these two rows are not touched, those don't change. So that's 2 and 2. However, 4 minus 3 is 1. 6 minus 5 is still 1. Okay, so sometimes they change, but in this case it didn't change. Okay. All right. Now you have 2 and 2, so that's a tie. And I guess there are some rules for which to take if there's a tie, but it really doesn't matter. Let's just use the top left corner, or the either that's on the top, or in the case of columns, use the one in the left. So it really doesn't matter. Okay. So I'm going to use this one because it's above this one. So I choose to fill this in. And I like this because that's actually the smallest number in 3, 5, 4, 6. So even in the view of minimum method, this is the right choice, right? So you have 300 available, but 150 is the remaining capacity, so you're going to put 150 here. 150 minus 150 is 0. Since it's 0, it's 0 here. 300 minus 150 is 150. All right, and then you have 5 and 6. Now you can't talk about any penalty because it's just one number, right? And it's kind of obvious what to do because you only have 150 here and 50 there, and 150 plus 50 is 200, so it meets all the capacity, and that's it. That would be the Vogel approximation method.